I'm Vinay. Uh, me and Amit are going to talk about simplifying DevOps with using Jupyter Notebooks, right? So, kind of a different use of Jupyter Notebooks that we want to orient ourselves towards in this talk. Uh, my background, I got introduced to Jupyter Notebooks around 2016 or so, when I started building Lyft's machine learning platform. It's all geared towards a system that we built over there called LiftLearn, which leverages Jupyter Notebooks very heavily for model training as well as deployment, right? And I was like very fascinated with this idea of like code as well as the inputs as well as the outputs coming together rather than living separately, right? And was always fascinated about how it can be used in other places. Amit here, who will also be part of this talk, is creator of ReviewNB. It's a tool for code reviewing notebooks that he talked about yesterday as well. And before that, was also interested in the use of Jupyter Notebooks, specifically for DevOps applications, and built an open source system called Nudge for that. So we are going to basically like pour our learnings in this talk and see how Jupyter Notebooks can be used for DevOps, right? And specifically incident management. So this is going to be our brief agenda. So first we'll look at just to get everyone on the same page. Just look at like the typical incident management workflow today, right? Like what is an incident and how it is managed today in enterprises. Then the problems with the current workflow, then the solution that we have come up with using the notebooks which addresses these problems, and then Amit will take over and do the demo, as well as the demo brings its own challenges, so we'll go over those as well and propose their solutions. Before I move on to the core of the talk, just want to understand and get a feel from the room, how many of you have used notebooks for something that isn't, say, data science or analytics or education? Any other applications? Yes, sir.
Some DevOps stuff.
Oh, DevOps, great. We'll probably learn from each other during this talk. Yeah. I think you had your hand raised. Yeah. Sorry, what? Oh, publish articles and so on, right? That's a great use, right? Like publish blog posts and journal articles and so on. I think there was another hand I saw. Okay, here.
Incidents, events.
Oh, incident events, great. Yeah, so we are great to see that like there is use of notebooks beyond these traditional applications, because it's a very powerful paradigm that we would really like to see like the world to know about, right, for other use cases as well. So uh, let's first look at, right, get on the same page regarding incident management, because not everyone necessarily knows what exactly we are talking about, right? So what is an incident really, right? So it's an event that disrupts normal operations, right? Typically in a service or in a microservice. So you are getting like your service is running using certain characteristics, right? Latency or errors or some sort of responses that you usually expect. And any deviation from that response, right? Like either the error rates increase or the latency increase or uh, some output, right, is not typically how it should be, right? Like the range of that output has changed, is basically called an incident, right? And it typically causes service degradation or outage, right? So there could be services that are not available for other people to use, or they might not be as available to the level that they usually are. So that's basically what we mean by incident, right? Like a degradation of the service. And the incident management typically happens in these areas, right? So first, bots is you identify the incident. So identification is done through various tools, right? Like typically like alarms or monitoring of metrics of the service, and then put in some thresholds to get someone reached, right? So that's the identification part. The second part is you respond, right? Typically, like after the incident is identified, like someone would get paged, and we'll go over a real scenario later. But some engineer will get paged, and that person will come in and do some analysis and figure out what exactly is going on. Based on those insights, there will be certain theories that will be formed, and that person will, or the engineer will try to resolve that incident. In a happy case, the incident gets resolved. In some cases, more people will need to be involved. But in the end, right, like once it's resolved, you go back and learn from it. And that will typically involve changes in your processes. So maybe like certain checks that you need to add, certain more test cases that you need to write, some deployment processes need to change, and so on. So this is the typical incident management lifecycle, and we believe like Jupyter actually fits in these middle two boxes, respond and resolve. That's what we will be focusing on, right? So we are not really focusing on the other two, but responding to the incident and resolving it is what we'll talk about more. So typical scenario would look like this: an on-call gets paged, say 2 a.m. No one likes to wake up at that time, but when the alarm goes off, you wake up, looks at the higher rate ticket that got fired. The on-call engineer will look at like service logs, recent deployments, look at some relevant documentation in Wiki or Slack, similar tickets in the past, might perform some actions such as restart a service, roll back a deployment, and the issue gets hopefully resolved quickly, right? So the middle two boxes, like the middle two bullets over here, are what we'll focus on, like the respond, like basically like the respond to the event as well as the resolution. So let's dive deep a little bit into documentation. How is it done today? So the common ways is either you have wiki articles, right? You will have like some notes that people will keep on adding on the wiki pages. You may have some Slack threads, right, where people can go back and search for what had happened in prior incidents, as well as you have past tickets, right? So typically PagerDuty or other services that are similar, which will be tracking the history of tickets that the team had dealt with. So the problems with these, first, it's written in English, not in code. So it's how to keep current, right? And the steps might be unclear. Like what might be clear to the writer might not be clear to the reader. So you may have like a step like say rollback deployment, right? A new engineer joining the team doesn't know how to roll back. Even if there are some code snippets, right? So you can like have markdown files or your wiki pages, like to have certain code snippets that are present. But the problem is they need they might not be runnable on your laptop, right? Like they might be needed to be run on a particular machine, need credentials to log into that machine, or need certain environments, certain packages to be installed, right? So the environment is really not the same. Even if you write the code steps, like you still need the environment. And following the instructions is error prone, right? Like you might have in your documentation, step 1, log into the machine, step 2, execute, go to this directory, step 3, execute this command, step 4, look at this log file. But someone in a high stress situation, right, like when services are not working and someone is trying to copy paste this at 2 a.m., right, like might miss a step in between and disaster can even further happen, right, because of those missing steps. These are manual and time consuming, right? You are going to go to many different dashboards. It takes time in a high stress scenario. You'll need to log into different machine. Again, takes time, getting the auth takes time, and so on. And last but not the least, most important one is there is no audit log. So these engineers might be running something, right? And like there are many times enterprises have compliance and security requirements which require them to go back and check what was run, right, and perform the audit. But there is no audit log in these ad hoc scenarios. So enter Jupyter, right, in our solution. And what we are proposing here, and we'll go over the demo in 1 minute, is instead of wiki pages, we maintain the documentation as well as code actions in Jupyter Notebooks, right? So there is no wiki, there is no Slack, there is no PagerDuty past tickets. It's all Jupyter is the one entry point that people would be entering, and all the previous shortcomings get resolved. So it's a very simple approach, like conceptually very simple. Some difficulty in implementing in practice, and we'll go over those. But simple approach with many advantages, right? So it's one rain to rule them all. you basically have only one place to go to rather than different dashboards, different machines, SSH here, run something there, etc. It's very quick, right? So there is, say, check database latency, right? Like if there is certain command like this, it's just one notebook cell execution, right? If you have prepared it correctly, to plot the latency graph and look at what's happening, right? Rather than going to some third-party UI and like trying to figure out how to log in there, and especially in the middle of the incident. It's very precise. Like one example here is like, let's say, again a DB incident, right? Like you might want to promote your RAID replica, which is replication of your database, to master, right? To make it primary, because maybe the existing primary had some issues, got corrupted or so on, and so you're going to start off from what you had is the good state. So it might have like 10 steps to actually promote it, right? Because you want to divert the current traffic to this, right? So you have to change many of the configurations, load balancers, etc., right? Depending on your setup. But in code, it's very precise when you actually do it across multiple services, right? Correctly in code, so that there is no human error involved. Someone actually had done this before, wrote it the correct thing in code, and you just execute that. And last but not the least, there is an audit log, so that people or like the security team can actually have what commands were run. So now, without further description, let's launch into the demo. So Amit.
Sure. Thanks, Vinay. So he talked about what are the problems with the current methods, right? Like how do you existing wiki documentation and Slack and PagerDuty docs kind of have some limitations. So what we're proposing essentially is Jupyter Notebooks can be extended to do incident response. And both of us have worked at Amazon, so we know on-call pain and how difficult it is to kind of responding to these services and outages to the services in the middle of the night. So this demo is it's like a couple of minute video. We'll go over the how an example of an incident and how Jupyter Notebooks can be used to solve that incident. So let's play this. So it's typical. You get a Slack alert. You're an on-call engineer. This alert says high latency on XYZ API in US East. So ideally, inside of that description of that alert itself, you have a link to a Jupyter notebook to resolve this incident. So the on-call engineer clicks on that link. Hopefully, there's a login that's powered by Jupyter Hub. You log in, it deep links into the exact notebook you want. These are already built documentation, say troubleshoot high latency. These are some of the things can happen. First step is check if latency spike correlates with the latest deployment. There's some change that got pushed, that got problem. Then you can see the plot. Right after the latest deployment, there's 2 spikes in the latency. So the engineer thinks there's some problem with that. So what do? You want to quickly resolve the incident, you just roll back the latest deployment. So you just roll back your code. He imports a method, just execute this cell, right? Depending on the result of the previous one, he executes. Rollback is async operation, so Jupyter Notebook output gives you the progress and shows you 100% rollback. Sadly, the problem is not solved even after the rollback. So it goes on. The next step is to check database for long-running queries. So this notebook, they connect to the a PostgreSDB, and they find some. There's an exact. One query has been going on for a very long time in this example. So they go and kill this long-running query to free up the database. This case, they're editing the code cell, but this can easily be an interactive element, like an IPy widget in a text box or something to put that process ID in. They execute that, so that query got killed. And the last step is they want to actually download the slow query log from the database and dive deeper into. There could be more queries that are creating this problem. So we just looked at what all is possible, right, in a Jupyter notebook to do. You can look at plot deployment times and the query latencies. You can do SQL queries, connect to them. You can do rollback a deployment. Today, in most companies, if you were to do this, you'd go to 10 different dashboards. Right? You'd go to AWS console, you'd go somewhere else to do rollbacks, you'd go somewhere. Jupyter can actually streamline this in one flow and in very precise, quick actions, basically give the on-call engineer some of his sleep back. So, okay. So far we've all given you like a hunky-dory, right? Nice. How can Jupyter be very good for this? But of course, there's some challenges when you want to use notebooks for DevOps. And we'll look at some of the challenges. First is too much code. So as Vinay said, I tried to build this this back in 2017, 2018, before review and to kind of use notebooks for DevOps. And I tried to do, I'll show you example. This is the code to do rollback deployment on AWS ECS. And this is not even entire code. There's more to scroll down. So hundreds of lines of code. Even if all of the tools have API, to actually use them, you have to write a lot of code. And this is ops, okay? The people are not going to invest so much time writing that much code, so there's not enough ROI. So if you ask them to do, hey, write a code, and then just give them AWS docs, they're not going to do it. Like, it's just operational stuff that might or might not get used, so it's just too much investment. So how do we solve this if you're proposing this? The solution is, I actually built a Rubik's library. It's an open source library to do rollback. So the library actually, it has integration tied up and give you high-level methods to connect to Kubernetes, connect to AWS ECS, and there's a couple of other things. Of course, that library could be used to extend to more things. So in this case, the person has to just say import rollback deployment, and then just call that method with your service name and your cluster name. So all of these kind of high-level libraries can be built so that anybody using Jupyter for DevOps could use those libraries instead of writing code directly against an API of AWS services or Prometheus or something like that. Nice thing with Jupyter Notebooks is that the outputs and all can be very interactive. So in this case, rollback deployment is not an instantaneous operation. It takes maybe 5 to 10 minutes to roll back a deployment across your cluster. So this library actually uses interactivity and shows the output as the progress bar as it's actually happening on your cluster. So you could pull progress and do a lot of cool stuff. And you've built it once in well-tested library. Could be amazing to use that inside of Jupyter Notebook and do DevOps. Second challenge is obviously the consistent execution environment. Imagine you've written all of these documents painstakingly in your notebooks, and come incident, and you try to run something, and you get module not found error. Oh, you can't actually run your notebook because of XYZ reasons, like on your local machine, you don't have access to this. There's VPC, there's all kinds of problems can happen if you have not the right environment, dependencies and connections and all of that. Turns out it's a solved problem, right? Our solutions is you could essentially use like virtualenv or Conda or Docker to have a consistent environment and give your team instructions on how to actually use those notebooks for DevOps purposes. So with a link of click with certain setup done beforehand, an on-call engineer can just use this. Or even ideally, the second line, Jupyter Hub, it's a single, like you could predefine an environment and people just log into there, as you saw in the demo, and use those machines remotely. So they have all of the environment set up, all the libraries required ready. So you don't run into this issue of, it's actually not executable on your machine type of issue. Or ideally, Jupyter Lite, where you don't need to actually connect, everything runs in your own browser. So that would be a dream come true if that actually worked for all of these cases. Third and last challenge is, I tried to build this as a startup back in the day, right, like DevOps for Jupyter. I still think it's a very cool idea. It can be done. I moved on to something else, but one of the pieces of feedback when I tried to pitch this to practitioners of DevOps, why don't you use Jupyter for solving your things? And they said, it looks cool. It's an interesting idea. And they would go and try it out, and they could come back with saying, hey, this is good, but if you're going to use notebooks for writing ops code, it's almost production code, right? It's got to be that level of we need all of the stuff. Like we need Version control, testing, CI/CD, code reviews, all of that stuff got to be in place before we can use notebooks to write any of our ops code. I'm like, okay, this seems reasonable. And then I tried to find the solutions for all of those things back 4 or 5 years ago. I thought this probably exists, but sadly it didn't, right? Not all of them were solvable. But today, this case had changed. I think there are existing tools here you can use for version control, GitHub, GitLab, there's Jupyter Lab extensions, there's NBDIM, NVDev. The first line is just usually for version control and pushing notebooks. You can use NBDIM or NBDev to do merges and local defs. You could use review NB for code reviews. If you don't even want to use Git, you could use, there's an S3 contents library, which you can change the backend of your Jupyter Notebooks to store notebooks on S3, right, and version control it there. There's a bunch of libraries in testing in CI. I actually open source Trion, the first one, but there's others, right? You can do testing today in notebooks. Obviously, all of these tools exist. So I do think that the problem of 4 or 5 years ago is solved. Like there's a lot of tooling around that's present today to use notebooks with DevOps, but I do think there is a couple of open challenges, and I don't know good solutions to those. Maybe we could talk about it, and if you have any ideas, you could tell us. I think these three kind of key areas to use notebooks for DevOps are still open challenges. First is granular access control. So say you have 500 notebooks and a few thousand people in your company. You don't want everybody to be accessing every notebook, right? You need some kind of viewer level permissions and subset of those. I don't know any solution with Jupyter Hub which gives you this granular access control. Searchable and shareable notebooks. If you're going to use notebooks for DevOps, it's essentially documentation, executable documentation. You want to be able to quickly search with a search string, and when you find certain results, be able to share it on Slack with your friends, with your team, to kind of work on it together. I don't know anything that's out there that's plug it on top of Jupyter Hub and do searchable, shareable notebooks across hundreds of notebooks. Maybe something exists, and you can tell me. And credential storage. Any ops work you do is going to be talking to a bunch of services, and you essentially need to use SQL credentials or all kinds of API keys and stuff like that. There are some solutions here which you can use Kubernetes secrets manager and stuff like that, but I'm not very well versed with it. So there's got to be a way to safely distribute these API keys along with access control and stuff like that. So we got to kind of solve these three open challenges. But if the Jupyter community as a whole can solve these things, then Jupyter, the notebooks for DevOps, is just one good use case. But if we zoom out from that use case, what we're essentially proposing is executable documentation powered by Jupyter, where each of the document is shareable, searchable, executable, and version controlled. And there's many use cases for this, right? Like you can use it across different analytics, reporting. I think Thomas was alluding to this in his talk this morning. It's like this, we could really expand the Jupyter's usage across outside of what current data science and education space that it is in. It's amazing technology, has some limitations, but if you could solve this either as community contributions or even as a sub kind of company, that could actually be really cool. That's all we have for today. Thank you. If there's any questions, open to talk. So yeah, the incident management part, we didn't cover this here. It's what we're, as you were saying, we're only doing resolve. So there's the entire ticket management, severity of tickets, and level 2, level 3. That's sort of outside of this.
Yes, repeating the question. So the question is about audit log and how does it track right here. Yeah. So what we are proposing here is Jupyter Notebooks are actually hosted centrally, right? So users are not running it on their laptops and so on. And the central place basically is the way of tracking all the executions of the notebook that had happened in the past. And that's very much necessary because the secrets is like a big issue in DevOps, right? Like a lot of times, like people just struggle getting what is the right way or where the secret is stored, right? So the central place is needed, and that's the way to get the audit lag as well.
Yeah, but we should probably clarify. This probably could be even open challenge because right now there is no way. Like, it's essentially we want to audit every cell execution, timestamped, and who ran it and stuff like that, and that could be built. And I think these folks have built it in this talk, as Thomas said, at JPL. But that can be done as something that if these guys can open source it, that could be wonderful.
That's a pitch for you to open source it.
Go for it.
Do you have a GitHub repo with any? Yes. Yeah.
Yeah, so Rubix is the name of the library. So you can search for nurch/Rubix or just Rubix library on GitHub. That's the open source kind of place where we built the library to do all of this code to do DevOps stuff. High-level APIs is essentially a library to communicate with other tools from Jupyter. Yeah.
That's great. Yeah, just repeating your suggestion for the recording. So suggestion for searchability is like have notebooks have the folder structure such that it's indexable by sprints, right? And then you can search. Great suggestion. Thanks. Yes, question.
Okay, yeah,
that's
we should
great.
check it out. Yeah, I thought the Jupyter book was more about authoring the book itself, like all of this, but I should probably check it out and. Oh, okay, it ticks these boxes. Nice. Okay, yeah, thanks. That's a good suggestion. Go for it.
You said you presented that solution to some ops teams. How would they react? Would they try it out and be happy about it?
Yeah. So I proposed this as a nurse, as a project in 2017, 2018, and they were actually excited to try it out. And this is like early adopters, so they wanted to try it out. But they ran into these challenges. So
Yeah, I think it's much more pitchable right now than it was like a few years ago because the ecosystem has come along a far way.
all right. Yeah. Thanks, guys.
Is it done?